Welcome to homework.
Given the function f of x equals x cubed minus 3x squared minus 3x plus 6, to use the intermediate value theorem to show that there's a root between 3 and 4 would mean we want to find f of 3 and we want to find f of 4. So let's start by finding f of 3. That would be 3 cubed minus 3 times 3 squared minus 3 times 3 plus 6, which is negative 3. And f of 4 is negative 27. Oh, nope, we did 4 cubed there. It is positive 10. There we go. And since there's a change in sign, negative to positive, and these functions are continuous, there's a 0 between them. So this shows, since that's negative and this is positive, that there is a 0 between x equals 3 and x equals 4. We want to use Newton's method to approximate the root to decimal places. Since we're going to go from the interval from 3 to 4, let's first figure out which one we're closer to. We can do this by finding when f of x times the double second derivative of x, we want that to be greater than 0. Is meant to say f of x. Okay? And so let's find the derivatives. The first derivative is going to be 3x squared minus 6x minus 3. And the second derivative is going to be 6x minus 6. All right, so if we take f of 3 times f, the second derivative of f of 3, that would be, well, f of 3 was negative 3. F of the second derivative of f at 3 would be 18 minus 6 would be 12, and that is not greater than 0. Where f of 4 times the second derivative at 4 would be 10 times 24 minus 6 is 18. That is greater than 0. So let's start at 4. So our initial start will be 4. So our first term here is going to be the initial minus f of 4 over f of 4 over the first derivative of 4, which would be 4 minus, in the numerator is the function at 4, so that would be 4 cubed minus 3 times 4 squared minus 3 times 4 plus 6 over the first derivative at 4, and the first derivative would be 3 times 4 squared minus 6 times 4 minus 3. And so we get like 3.5238. And I'll use the whole thing because we want to do this until we're getting something consistent to 2 decimal places. So now it would be, I'm going to copy this. The nice thing about this. And we're going to go to the next term. So that's now going to be 3.5 to 3809 52381, and I'm going to copy that and paste that into all of my inputs. Make sure all of our inputs are covered here. Actually, can we make this bigger? That would be more helpful. All right, so I think we are good. I just deleted that one. Not that that'll make much difference, but that's okay. And we get 3.37. Okay. So now we're going to do this again. And we're going to replace all these with 3.37. 636428036 into the function and the first derivative. And we get 3.36. We got to be good to 2 decimals, so we're going to do this another iteration. And this time we're going to substitute 3.36161303 as our input. And we get 3.3614. So notice now we are good through 2 decimal places, 3.36.